So here's the second part of our one-sided limits video, and this is the existence of a limit theorem. Now this theorem is going to make a lot of sense to you because it's something we've been talking about for all last week. This theorem says if the limit as x approaches c of a function is L, meaning it exists and it's a single constant value, if and only if, that's a geometry term, the limit as x approaches c from the left of that function is L, notice the same as this, and the limit as x approaches c from the right of that function is L, notice the same as this. So remember, if and only if from geometry works both ways. This means if a regular, I'm going to call this, since it's not one-sided, a regular limit happens to be a number, then its one-sided limits are the same numbers. But it also works the other way. If the limit of a function on the left is a number and the limit of a function on the right is the number, then you can conclude that the regular limit of that function is L. Now that is something we've been saying since day one of limits. It's just all put together here in this single theorem. And that theorem is going to actually help us do these problems, these problems, like this. So your approach to a one-sided limit should be this. The limit as x approaches 4 from the right of this function is what? First thing to do is to ignore the one-sidedness of the limit. I'll explain why in a minute, but let's just go through it. So I'm going to say, instead of doing that limit, let's just do the limit as x approaches 4. So I'm going to factor as we go. Because it does factor x plus 8, x minus 4. You can see I probably should have said this before. But if you do plug 4 into this limit, you're going to get 0 over 0, which means it is going to exist. You're going to have to factor it. So I went ahead and did that. And then evaluate this limit as normal. This function 1 over x plus 8 is the function that agrees with the original function at every point except x equals 4. Plug 4 in and you get your limit. Now, that wasn't the question that was asked. The question was not what's the limit as x approaches 4, but as x approaches 4 from the right. But since we already did this regular limit and got 1 over 12, you can go back to this theorem, which says if you do that, this is a regular limit, then the limits from the left and the right must be that exact same number. So that was easy. I can conclude that, therefore, the limit as x approaches 4 from the right of that function is also equal to 1 over 12. That's it. Be careful going the other way. So say I said, if I knew a limit, say approaching the left was 3, I can't conclude this is true unless I show that the right part is also true. So let's do the next one. I'm going to take the same approach here. I'm going to pretend that the limit as x approaches -8 from the left isn't even there. I'm going to do it just the regular limit. It's the same function as before. So I'm going to jump down to that step. Now, when you plug in -8 here, you will get obviously 1 over 0, which means there's a vertical asymptote. So you can't use this theorem because that limit does not approach a specific constant number. But you can still analyze this. You know if the limit, if there's a vertical asymptote, the limit does not exist. But for a rational function, that would mean both sides are going to positive or negative infinity. So you know that this limit does not exist either. Now, the only addition you could say to this, for one-sided limits, you can specifically say, instead of saying vertical asymptote, you can say this goes to positive or negative infinity. For regular limits, you can't say that because each side may go to a different infinity. But a one-sided limit, it's either going to positive or negative infinity. The way to figure out positive or negative infinity is just do this. Since we're approaching -8 from the left, you can just plug in something close to -8 on the left, like -8.01. If you plug it into this function, you can see that this is going to be 1 over -0.01, which is negative. So you can say, and this is a legitimate answer to this question because it's one-sided, you can say the answer is negative infinity. You know it's going to be plus or minus infinity because of the asymptote, but if you plug in numerically a number to the left of 8, and you get negative, that's how you can tell it's going to be negative infinity. The reason that's important, I think, is because now when we talk about the graph of this original function, we know at -8, on the left side of it, it approaches negative infinity, so it looks like that instead of something. So I'm going, because I don't want these videos to be that long, I'm going to stop that video here before we get to the next two problems. If you need to review, obviously just please review. If you have any questions about anything I did in the video before we get to class, just let me know that as well. So I'll see you at the next video.